So we're on the last page on activity B. So page 5, set up the gizmo, return to original state and restart. Coral disease often crop up in the reefs and are rarely stressed by high temperatures, high nutrition levels, or low pH. To model these conditions, select the ocean conditions and set the ocean temperature to 29 degrees Celsius and the ocean pH to 7.7. Then select the land use and the agriculture to 50%. Finally, select the disease, set the black band infection rate and the white band infection rate to 100%. Whoa. Alright, so let's do that all together. First, you want to return to original settings and restart. Alright, ocean conditions, we'll start there. It says it wants the ocean set to 29 degrees. So we go here, bump it up to 29 degrees, take the ocean pH down to 7.7, then select land use and agriculture to 50%. So we go down to land use, agriculture up to 50%. Finally, select disease and set the black band infection rate and white band infection rate to 100%. Go down to disease, white band, and black band. So those are all the things that it wanted us to do. We haven't hit start, but poor little animals don't even know what they're in for right now. Now, select the summary tab. What is the current coral stress level? So you're looking here, down. So the coral stress level is what you're looking for right here. Predict. How do you think the stressed corals will respond to the disease? So that's your thinking. You do not need to know this as long as you're writing something that makes sense. That's all it's looking for. Number 9, experiment. Click advance year to 20 years. How does the impact of the disease in a stressed reef compared to the impact of the disease in a healthy reef? To make a direct comparison, run the experiment with the original settings of the black and the white infection rates. So what you're doing is we're going to advance this 20 years. Oops. So how does that compare to what we were running previous? Prediction. On the Conditions tab, click the Return to Original Settings and Restart. To model the die-off and long spine urchins in 1983, set sea urchin infection rate to 90%. Before we run it, what do you think is going to happen to the reef if we lose all our sea urchins? So we restart. Okay, so everything goes back to original state when you hit original state. We go to disease. We're going to increase the sea urchin infection rate to 100%. And then we are going to advance it 20 years. Okay. If you're not sure, you can always look at your sea urchins. which is the pink one. I can't even see it. Oh, there it is. So within the first year, they all die out, and then the coral reef responds. You can look at the algae and the parrotfish populations, along as the staghorn coral and the queen angelfish and coral star or boulder star coral. Infer. Parrotfish rely on coral for protection and shelter. Look at the parrotfish population over time. Why did the parrotfish population increase at first, then later decline? So we're looking at the parrotfish population. This one right here. They're saying it has a slow increase and then it declined. So why would that have happened? Think about predators and also think about places it could stay.